Children, we have discussed about potential energy of a point charge in external field, potential energy of two charges in external field. After that, potential energy of a dipole in external field. That's we are going to discuss today. First, revisit the chapter 1. That is, a dipole is placed in electric field E at an angle theta. See here the diagram. A dipole of length 2L is placed in an electric field at angle theta. So, the force on positive charge and force on negative charge is here given. What is the net force on dipole? Any one of you can answer. Yes, that is net force on dipole is 0 because these two forces are equal and opposite. Is there any translatory motion of dipole? Yes, no, because net force is 0. Is there any rotational motion? Yes, due to torque, and that torque is P cross E. Up to this we have learned in chapter 1. Some more here recapitulation about the torque. The direction of the torque perpendicular into the plane formed by P and E. So here if the angle between dipole moment and electric field is theta, then torque is downward, that is into the plane. If theta is 0, then torque will be 0 because tau equal to P sin theta. If 90 degree, then its value will be maximum and that is equal to P. If theta equal to 180 degree, then torque is 0. So now consider an external force. Try to displace this torque, this dipole opposite to the field without any angular acceleration. Means the angular speed is infinitesimally small. Then what happens? Some work has to be done against the electric field and that work will store as potential energy. So start today's discussion, that is work done on an electric dipole in uniform electric field. Here consider a dipole of length 2L is placed in a uniform external electric field E. So the forces on positive charge and negative charge will be opposite to each other. Now the external force displaces this dipole by a small angle d theta. Means the total angle from the reference line is theta 2. From here we can see if we take the initially dipole is at angle 0 degree and it displaces from here it is theta 1 to theta 2. Then the work done will be tau d theta. So now mathematically dw equal to tau d theta and we substitute the value of torque, that is P sin theta. So the total work done will be integration of P sin theta d theta from theta 1 to theta 2. And we are knowing the integration of sin theta d theta, that is minus cos theta. So if we substitute the proper limit, we will get W equal to P cos theta 1 minus cos theta 2. This work done is stored as electrostatic potential energy. Now we know in a conservative field, arbitrarily we choose a point where potential energy is 0. And we know cos 90 degree is 0. So if we can take initially dipole at 90 degree with the electric field, it is arbitrary chosen. You can choose any point, any position where potential energy is 0. But accordingly you have to modify. So if we take initially dipole, that is theta 190 degree and theta 2 is theta, then potential energy U equal to minus P cos theta, and we know AB cos theta is scalar product of vector A and B. So here P cos theta will be scalar product of dipole moment and electric field. Now if theta equal to 0, then potential energy will be minus P. It is a stable equilibrium. Theta 90, then potential energy 0. If theta 180 degree, then potential energy, that is maximum, that is P, and that is called unstable equilibrium. So these are the different cases. In examination, condition for a stable equilibrium, unstable equilibrium are being asked. Now, read the paragraph given here carefully. A molecule of a substance has a permanent electric dipole moment of magnitude 10 to the power minus 29 coulomb meter. A mole of this substance is polarized at low temperature by applying a strong electrostatic field of 10 to the power 6 volt per meter. The direction of the field is suddenly changed by an angle of 60 degree. For simplicity, assume 100% polarization of the sample and 1 mole equal to 6 into 10 to the power 23 molecules. Now, hope on the basis of this paragraph, all of you can answer. First is, what is the total dipole moment of all molecules? What is dipole moment? Just do the calculation. Here one molecule having dipole moment 10 to the power minus 29 coulomb meter, and all molecule here, and that is given 1 mole. So the total dipole moment will be 6 into 10 to the power 23 into dipole moment of 1 mole molecule, and that will be 6 into 10 to the power minus 6 coulomb meter. Now can we compare here loss or gain in potential energy? First, initial potential energy, that is minus P cos 0 degree. Give the value of P calculated above, and electric field is given, that is 10 to the power 6 volt per meter. Theta here initially 0 degree, and on simplification we will get U initial minus 6 joule. And in the paragraph it is given the direction of field suddenly changed by angle 60 degrees. So final potential energy will be minus P cos 60 degree. That's value is minus 3 joule. So now change in energy is, that is minus 3 joule minus of minus 6 joule. What will be its value? Plus 3 joule. So here change in energy, that is final minus initial, is positive. So that is loss in energy in the form of heat or electromagnetic radiation. Thank you. Do the derivation part, numerical part carefully. Next we will learn numerical problems related to the capacitors, combination of capacitors, energy stored in capacitors, numerical from all these parts. Thank you.